Hey, welcome back guys. So I showed you how to do sine squared, integrating sine cubed, and now it's time for integrating sine to the power 4. It's important to note that you shouldn't approach these questions by trying to memorize every single situation you'll encounter, but rather try to understand the idea, right? So as our powers get bigger, our job is basically to try to use our various identities to reduce the power, okay, to eventually get it to a point where it's something that we can integrate, right? So in this case, we have sine to the power 4. Okay, one very good way to reduce sine squares, like sines that have powers on it, is something that we already looked at, right? So cos 2x is 1 minus 2 sine squared x. So the double angle from cos gives us a relationship between this guy and a sine squared. Right, so if I just make sine squared x the subject, we get this, okay, which hopefully we're familiar with up to this point. And in this question, we can say, okay, sine to the power 4 is just this squared, right? So it's just that squared, right? And we can already see just by looking at it, we got something that was a power 4 to just a power of 2. Right, so now we're going to just need to do a little bit of algebra, a little bit of work. So a quarter at the front. And this, let's expand, let's expand it out. 1 minus 2 cos 2x plus cos squared 2x. Okay, let's integrate what we can. So quarter. This is integral of 1 is just x minus the integral of negative 2 cos 2x. Okay, so this should be sine 2x over 2. Yeah. Let's close the bracket, plus a quarter of cos squared 2x. Okay. Now, this part here is something that we can just kind of simplify in the next line. This one, the cos squared, is a question that, again, we should already know how to do up to this point. So let's just write out the double angle again. Cos 2x equals to 2 cos squared x minus 1. 2 cos squared x equals to cos 2x plus 1. So cos 2x equals to half. Like that. Also, let's just write this one more time and replace x with a 2x, since we've got a 2x here, which means this is 4x. Okay, we're almost there. So let's say quarter x minus sine 2x plus a quarter, and we're going to integrate. Let's bring the half out the front, and we're going to integrate cos 4x plus 1, which is something that we definitely can integrate. So we should see the light now at the end of the tunnel. Let's expand this. X on 4 minus sine 2x on 4 plus 1 on 8 sine 4x on 4 plus x plus c, which equals to Now we have a x on 4, and then we have a x on 8 over here, right? So if you add them together, we should get 3x on 8 minus sine 2x on 4 plus sine 4x on 32. And hopefully that's the answer. Yep, that's the answer. Okay, so like I said, a lot of this question, it seems like it's difficult, but it's actually more like work than anything. As long as you understand just using knowing how to use the double angles to reduce the powers. And cool. Okay, so that's it for this video. I'll see you in the next one.